Hello everyone, I am back again. My name is Arindiri and I welcome you all to my YouTube channel. So this video is a continuation of our DSA series, and we are going to continue our math series, our basic mathematical series, where we are going to talk another question on basic mathematics. So in this video we are going to discuss a problem, reverse the number. Reverse the number. All right. So what this question says, let's say we have a number 1, 2, 3, 4. We have to reverse this number. For example, 4, 3, 2, 1. So this is an input number and we have to reverse this number like this. All right. So we have to do this. All right. So how can we do so? How can we reverse the number? So in this video we are going to use again the modulus operator. We have talked about this operator in our previous video where we were talking about the extraction of digit. All right, so we are going to use modulus operator in this question also. All right, so how can we use this? For example, let's say this is our input number. What if I take modulus of this number by 10? I'll get the last digit, and after doing this, what I can do, I can divide this number by 10. I'll get 123. All right, 123. So you can see here that I have extracted the last digit successfully. So what I can do, I can store this number in any variable. For example, I have a variable reverse number. Initially I will initialize it with 0. All right, so what I can do, I have extracted the last digit. I can assign this to this reverse number. I will not directly assign the reverse number. I will not directly assign this extracted value to this reverse number. First of all, we will have 0. We will multiply this number with 10 and then we will add this last number. We will get 4. All right, so after doing this, we will have 4 value in this reverse number, and then we have divided this number by 10 and our answer is 1, 2, 3. So here our first pass is completed. First pass. All right, what we can do now, we can pass this output as input in our next pass. So this is our output. We'll pass this as input in our next pass. So our input will be 1, 2, 3, and we can take modulus of this number by 10, and again we will get the last digit as our input. And then what we will do, we have this reverse number and we have 4 in this reverse number. We will multiply this with 10 and then we will add this number. What we will get, 43. All right, so we have successfully added this second last digit to our reverse number. All right, so we have now 43 in this reverse number. Now what we can do, we will divide this number by 10. All right, we will get 12, and here our second pass is completed. Now we can pass this value as input to our next pass. So we have 12 as our input. Again we will take modulus of this number with 10. We will get the last digit again, and again we can add this number in our reverse number. How? Again we will multiply this reverse number with 10 and then we will add this last digit to the reverse number. All right, so what we will get, 430 plus 2, 432. All right, so we will have 432 in our reverse number variable. All right, so here our what we can do after doing this, we can divide this number by 10 and we will get 1. All right, so here our third pass is completed. So this number is input for our next pass. So we will give this number to the next pass. 1 modulus 10. Again we will do the same step, and the answer will be 1. Again we will multiply the reverse number variable with 10, and we will add the last digit, which is 1. You can see here this is 1, so we are adding this here. And after doing this in a reverse number variable, we will have 4, 3, 2, 1, and then what we will do, we will divide this number by 10. 1 divided by 10, and we will get 0. Here our fourth pass is completed, and now you can see that our number becomes 0. So we have no need to iterate further, we have no need to calculate it further. All right, and you can see in our reverse number we have the reverse of the input. All right, so our input was 1, 2, 3, 4, and in reverse number variable we have 4, 3, 2, 1, which is reverse of this number. All right, so let me write the pseudocode for this, and after writing the pseudocode I will discuss some edge cases where this can fail, this approach can fail. All right, so let me write the pseudocode. All right, so obviously we will have a reverse number variable. Initially we will initialize with 0. Now what we will do, we will run a while loop, and the condition will be n which is greater than 0. I will change this condition after writing this pseudocode, because I have to introduce some edge cases to you. All right, so this is, for now this is our condition in while loop. What we were doing, we have the input value, and we were taking the modulus of this input value with 10. So what we will do, we will get the last digit after doing this operation. So we will have a last variable where we will take modulus of this input by 10. We will get the last digit. Then what will we do, we will multiply this reverse number with 10. All right, reverse number multiply with 10, and then we will add what, this last number. And after doing this, what we will do, we will initialize this complete value in our reverse number. All right, and after doing this, what will we do, what we were doing, we were dividing this number by 10. So the number is n, and you are dividing this number by 10, and again we have to pass this output to the this output as the input in next pass. All right, so we have to assign this calculated value in n again. All right, and here our while loop will stop, and then after completion of this while loop you can return the reverse number. All right, so let me try run this code, this pseudocode. All right, so initially we will have 0 in our reverse number. We are running the while loop till our n is greater than 0. So let's assume that this is our input value, this is our input value. All right, so 1, 2, 3, 4, which is greater than 0. So we are taking modulus of this input number by 10. We are getting the last digit, and then what we are doing, we are multiplying this reverse number with 10, and then we are adding this last digit. So what is last digit? Last digit is 4, and in reverse number we have 0, and we are multiplying this number with 10. So this number, so we are multiplying 0 with 10, and then we are adding this last digit, which is currently 4. So we are adding 4, so this complete value will become 4. So we will have 4. We are again assigning the calculated value in reverse number, so we will have 4 in reverse number, and then we are dividing this number by 10. So after dividing this number by 10, we will get 1, 2, 3. All right, and then our while loop is the first iteration is completed. So now we are passing this output, this result, as input in our next pass. So you can see 1, 2, 3 is still greater than 0. So we are again taking modulus of this number with 10. we will get the last digit. So now we have 3 in our last variable and we have 4 in our reverse number. We are doing multiply. We are multiplying this number with 10, so the number will be 40, and then we are adding this last digit in this number, so the number will be 40 plus 3, which is 43. All right, so 43. And then what if we are doing, we are dividing this number by 10, we are getting 12, and then our second pass is completed. Now what we are doing, we are passing this number to the next iteration. All right, so you can see that 12 is still greater than 0, so we are again taking the modulus of the number with 10. We will get what we will get, 2. You can see here, after taking modulus of this 12 with 10, we are getting the last digit, which is 2. So in our last variable we will have 2, and then we are again multiplying this reverse number with 10. So this is our reverse number, we are multiplying this with 10. What we will have, 430, and then we are adding this last number, which is 2, so the final value will be 432. All right, so and then we are dividing this number again by 10, so we are dividing 12 by 10, we are getting 1. All right, and you can see 1 is still greater than 0. We are again taking modulus, the last digit will be 1. Again we are multiplying the reverse number with 10. All right, and then we are adding this last digit. All right, so the last digit is 1. So after completion of this step, we will have 4, 3, 2, 1, and then again we are dividing this number by 10. So what if we will get, what will we get after dividing this number by 10? We will get 0, and 0 is not greater than 0. That's why in this step our while loop will break. So the execution of while loop is completed, and now you can see in a reverse number variable we have the last digit, in a reverse number variable we have the reverse of the input. All right, so the input was 1 2 3 4, and in reverse number variable you can see that we have 4 3 2 1. All right, so you can return this number. All right, so this is the pseudocode, and let me show you the code. All right, so yeah, you can see this is the pseudocode itself. We are using C++. All right, so this is our reverse number variable. Initially we are initializing with the number with the value 0. We are running a while loop till our n is greater than 0. This is our last digit, and what we are doing, we are taking modulus of this number with 10, and we are multiplying the reverse number with 10, and then we are adding last digit in this variable. All right, so and then we are dividing this number by 10. After completion of this while loop, we are returning our reverse number. All right, so let me run this code, compile and run. So you can see that our code is running successfully, and let me submit. Okay, so you can see that our code is successfully submitted. All test cases are running successfully. All right, so let me introduce some edge cases. What if our number is negative? What if our number is negative? What will we do? We don't have to do anything, we just change our base case. So what was the pseudocode? Reverse number initialized with 0. What we were doing, we were running a while loop. The condition was n is greater than 0. Now we will say that the n is not equals to 0, and the remaining code will be same. Last equals to n modulus 10. A reverse number will be reverse number into 10 plus what? last digit, and then we will divide this number by 10, and here our iteration will be complete, and then we can reverse the return the number, a reverse number. All right, so let me try run this code. So our the number is negative 1234, which is not equals to 0. So what we are doing, we are doing modulus of this number. So the last digit will be 4. All right, so this is the pseudocode for the negative number. So we have just changed the condition in the while loop, and the remaining code is same, and it will work. All right, so you can see that we have -1234, which is not equals to 0. So we will run the code. What will happen if you try to take modulus of 1234? We will get -4. All right, so we will have initially we will have 0. We will multiply this with 10, and then what will we do? We will plus -4. All right, so what we will have? What will we have? We will have 4. All right, and then we will divide the number with 10. So we will have 1 2 3 4 divided by 10. We will get 1 2 3. All right, -1 2 3, and then again we are running this while loop till our n is not equals to 0. All right, so you can run you can dry run this code for the complete number. All right, or you, if you want, you can take any other example. All right, so this is our first edge case. All right, so now let me introduce you second edge case. All right, so if what if our number is exceeding all right, our number is exceeding the range. All right, for example, in int type variable in C++, we are using C++. So in C++, the range of the integer is from -2 to the power 31 to 2 to the power 31 minus 1. All right, so let me show you what is the range. What will you get after computing this number. All right, so I have written the exact value because I don't have remember this big number. All right, so 241,748 3647. All right, so this will be our positive limit. All right, positive limit. So 2, what was the range? 2174 474 is our positive limit. All right, so an integer value can store this big value. If you increase this, like if you add one more, it will give you an error. All right, so the positive limit is 7. This number, this big. All right, so you can store this big number. All right, for 1, and the negative number will be minus 214,748,3648. All right, so this is the range of the int data type. All right, so the edge case is what if our value is exceeding this range. All right, so we have to write some checks. What we can do, let me show you the question first. All right, so this is the question. You can see here that cause the value to go outside the signed 32-bit integer range, I -2 to the power 31 to the power 31 minus 1, then return 0. That means if our answer, or if our value is exceeding this range, we will return 0. All right, so let me write the pseudocode for this. Obviously we will have reverse number initialized with 0, we will run while loop and till n is not equals to 0. All right, so what we were doing, uh, so what we were doing, uh, we were doing modulus, we were taking modulus of this n, and we were getting the last digit. All right, so last equals to n modulus 10, we'll get the last digit. So what we were doing after completion of this step, we were multiplying our reverse number with 10 and then we were adding this last digit. But what we are checking here, we are checking for the limit, the lowest limit and the highest upper limit. All right, so I have written the lowest lowest limit and the upper limit. All right, so this is the limit of integer data type, so we have to check before multiplying this reverse value whether this reverse number is containing greater than or less than our lower limit or upper limit. All right, so what will be the check, what will be the condition? We will check if our reverse number is already containing greater than our max limit, or if our reverse number is equal to max limit, max limit divided by 10. All right, max limit divided by 10, max limit, I will explain why I'm saying max limit divided by 10. All right, I will explain. So reverse number, if our reverse number is equals to 10, max limit divided by 10, and our last digit, what last digit is greater than 7, what will we do? If this condition matches, if this condition is true, we will return 0. All right, I will explain this in a while, but let me write condition for negative also. All right, so if our reverse number is containing number less than minimum limit by 10, what is our minimum limit? The minimum limit of the integer data type is this. All right, so if our reverse number is containing minimum limit by 10, or if our minimum limit, if our reverse number is equals to minimum limit by 10, and our last digit is less than -8, what will we do in this condition? We will return 0. All right, if both the conditions are not matching, what will we do? We will simply multiply this reverse number with 10, and then we will add what last digit, and then we will simply divide this number, the input number, by 10. All right, and then after completion of this while loop, we will return what will be return? Reverse number. All right, so let me explain this this condition. This is first condition, which is checking the upper limit. All right, and this is the second condition, which is checking for the lower limit. All right, so what I am saying, if our reverse number is already containing the value maximum, the value greater than maximum limit by 10, so what is our maximum limit? our maximum limit is 21474833647 by 10. What will be the value after dividing this? We will get this much. All right, this is the value of this. All right, so what I am saying, if our reverse number is already containing value greater than this, what can be greater than this? 214748364. This is our maximum limit by 10. What can be greater than this? 5. It is already out of memory. All right, it is already out of range. So simply we will return. If this condition is true, we will return 0. Or if our or we are checking if our reverse number is exactly equals to the maximum limit by 10. So this is the maximum limit. This is the maximum limit by 10, and our reverse number is containing this value. So what can we add? What can we add more? We can add more. We can add 7. All right. So what can we add more in this value to be in the range? So at max we can add 7. All right, if we add 8 here, the range will exceed. All right, so that's why we are checking if our reverse number is containing the exactly maximum limit divided by 10. So we are checking if our last digit is greater than 7. Why? Because our maximum limit is 7. All right, so if our last digit is greater than 7, let's say 8, so we will add 8 here and it will exceed the limit. All right, so that's why we are checking if our reverse number containing this much, so the last digit, so this variable should contain the value less than or equals to 7. All right, if the value is greater than 7, value will the answer will exceed the range, which the integer data type cannot hold, so we will return what? 0. Similarly, we are checking for the negative also. If negative number is containing minimum limit divided by 10, if negative number is containing less than minimum number divided by 10, we will return 0. Or if our reverse number is containing minimum limit divided by 10, exactly minimum number divided by 10, then we will check for the last digit. If last digit is less than -8, then we will return 0. If the number is greater than -8, we will think. All right, so what we are doing, if both the cases are not true, we are multiplying this number with 10, we are adding the last digit, and then we are dividing the number by 10, and after completion of this while loop, we are returning the reverse number. All right, so let me show you the code. So this is the code. All right, so let me run this code. Let me submit this. So you can see that our code is successfully submitted and we have solved this problem. All right, so thank you for watching this video. I hope you have understand the concept behind the limits and all. I hope you have understand all the edge cases. All right, in next video we will discuss some more basic mathematical questions which are important. All right, and then after solving 7 to 8 questions in basic mathematics, we will move to the main data structures like array and linked list and all. All right, so thank you for watching this video. We will meet in the next video. Thank you for watching.